All right, thanks for joining me today. We are going to continue our work with trig ratios, and we're actually going to apply these ratios to solving for right triangles. So if you're taking your notes, go ahead and get your journal out or your notes that you are paper notes. We're going to be on the second page of our notes 9.4 and 9.5. So we're on the second page. It looks like this. We have 4 examples here that we're going to go through in solving trig ratios. So here's some things that I want us to remember, right? Here's our first key. Remember our tips from the other day. Always start with your angle. That's the first thing that you want to start with. That'll help you figure out what the relationships are between the angle and the side. So always start with the angle, okay? Here's our second tip as we're creating equations and functions with these. Here's a tip. Set the equation up like a proportion. So what do I mean by a proportion? I mean equal ratios or equal fractions like this. So you want to set it up as equal ratios, equal fractions. And remember, to solve proportions, we're going to cross multiply and then divide. So just a quick reminder of this. Let's take this here. If I have 5 over x equals 3 over 6, if I cross multiply and divide here, I have 30 equals 3x. So we cross multiplied. Divide, we're going to get 10 equals x. Okay. So quick reminder of cross multiplying and dividing. I know you remember how to do that, but just a reminder. So we're going to think about these examples. All right. So let's take a look at our first one. We're first going to determine which trig function to use. So remember our trig functions that we talked about. So, toa. Remember that? SOHCAHTOA. Your SO is sine of theta is opposite over hypotenuse. Just a reminder here. Your ka is cosine of theta equals adjacent over hypotenuse. And then that toa is your tangent of theta equals opposite over adjacent. So keep those in mind as we go. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So remember, across the street neighbor, next door neighbor, across the street neighbor divided by next door neighbor. Just some little tips. I know it's funny to think about it like that, but it helps me to remember. Hopefully it'll help you to remember as well. All right, so let's move on to our first example here. And I want to find the missing measurement. Here's my missing measurement is x. They give us two angle measures here, so really we can pick which one we want to start with. Let's start with 21. So I'm going to start with 21. Now I'm going to look at the relationship of x to 21. Well, it looks like I have to go across the street to get to x, or across the triangle. So x is my opposite value. 9 is hypotenuse. So from 21, x is opposite, 9 is hypotenuse regardless. So I'm going to look at my trig ratios and see which one has opposite and hypotenuse. It looks like sine. So that's the one that we're going to be doing. We're going to do sine. So I'm going to write it down here just so I can remember. And remember what I said about setting it up as a proportion. I'm going to set this up. So it's sine of theta, which is your angle. So my angle here is 21, looks like this, equals opposite value x divided by 9. So you're saying, well, this isn't a fraction on the left side. How do I set it up as equal fractions? Well, I can put any whole number over 1, right? So that's how I set up my proportion. Makes it so much easier. So I'm going to multiply here. So I have x equals 9 times the sine of 21. Well, let's look at that in the calculator and see what we get there. So I have 9 times the sine of 21, and that is 3.2. And that's what we're going to use. We're going to just use our to the 10th, right? Or, oh no, it says to the 100th, sorry. So 3.23 is our answer, 3.23. So our equation is what we said here, sine of 21 divided by 1, right? We changed it to a fraction by putting it over 1 equals x over 9. All right, let's try our letter B. We have 2 angle measures here. We can choose either one. Let's try this one, 37. So I'm going to start from 37. Always start from your angle. And I need to find x. So let's see. X is, oh, he's right next door. He shares a leg. So this is adjacent, right? And this is hypotenuse because it's across from your right angle. So I know it's hypotenuse there. So let's see our equation here. What trig function deals with adjacent and hypotenuse? Looks like cosine, right? So cosine of theta equals adjacent over hypotenuse. So let's plug our numbers in. The cosine of 37 equals the adjacent value, x, divided by the hypotenuse value, 13. Equal proportions, I'm going to put this over 1 and cross multiply. So I have x equals 13 times cosine of 37. Let's plug this in the calculator and see what we get. 13 times the cosine of 37. We get 10.38. 10.38. So here's a tip. If I'm solving for a right triangle, I know that my numbers are going to be, they have to make a triangle, right? So I know if 13 is my longest side, because it's my hypotenuse, either of these two numbers has to be less than 13. So keep that in mind when you're plugging it in the calculator. If I got a 54 here, I know that that wouldn't be reasonable. So I probably did something wrong. Maybe I used a trig function and I should use a different one. So keep that in mind. So my cosine of 37, here's just my equation. I'm going to write it again, equals x over 13. All right, let's move on to letter C. Scoot this up a little bit so you can see it better. Okay, only one angle. Oh no, we're looking for both x and y. So it looks like we'll be doing this twice. We'll be doing two trig functions. Always start from your angle, 36. And from 36, x, I have to go across the triangle. So this is my opposite value. And y here is my adjacent value. And 8 is my hypotenuse, right? So let's solve for x first. It's opposite and hypotenuse. So I'm going to look for a trig function that is opposite and hypotenuse. It looks like it's sine, right? So I'm going to say sine of theta equals opposite divided by hypotenuse. Now I'm going to plug in my numbers. Sine of 36 equals x divided by 8. Make it a proportion by placing it over 1. We're going to cross multiply. So I have x equals 8 times sine of 36. Plug it in my calculator. Let's see. 8 times sine of 36 is 4.7. X equals 4.7. So I'm going to write down, oops, sorry, going to get out of my calculator there. My equation was sine of 36 divided by 1 equals x divided by 8. Now let's solve for y, same thing. except I'm going to be using a different trig function because now I'm dealing with my adjacent side and my hypotenuse, right? So adjacent and hypotenuse looks like we're using cosine again. So we're going to say cosine of theta is adjacent divided by hypotenuse. Plug in my values here. Cosine, same angle, 36, equals y divided by 8. Make it a proportion by placing that over 1. Cross multiply here. Y equals 8 times cosine of 36. Let's see what that is in the calculator. 8 times cosine 36. 6.47 or 6.5. Let's do that. 6.5. I know they said 100ths, but I'm really swaying it, aren't I? 6.47. I'm going against the rules here. 6.47. All right, then my equation was cosine of 36 divided by 1 equals y divided by 8. All right, that's a lot of work for that little triangle, but we found our values. And now I want to think, are they reasonable answers? So I'm going to look. My longest side is 8. Are my other two sides less than 8? Well, yeah, this one's 4.7 and that one's 6.47. So that those two make sense because they shouldn't be longer than 8 because it is a right triangle, right? And that your hypotenuse should be the longest side. All right, let's look at letter D and we'll be finished with our notes. You'll be ready to try some out. We're going to be starting with our angle, right? Always start with your angle. And I'm solving for x and y. So x is across the street and across the triangle, so it's my opposite value. And y is my adjacent value, and 11 is my hypotenuse. So to solve for x, I have opposite and hypotenuse. So we're going to do sine of theta equals opposite over hypotenuse. And I'm telling you, the hardest thing about these is just trying to decide which trig function to use. So we're going to say sine of 50 equals x divided by 11. Make it a proportion by placing that over 1. Cross multiply, so we have x equals 11 times sine of 50. All right, let's plug that in the calculator. 11 times sine of 50. Answer 8.43. 8.43 looks pretty good. Sine of 50 divided by 1 equals x divided by 11. All right. Last one, solving for y. We have adjacent and hypotenuse. That looks like a cosine. Cosine of theta equals adjacent over hypotenuse. So we have cosine of my angle, which is 50, equals y divided by 11. Make it a proportion by placing it over 1. Cross multiply, y equals 11 times cosine of 50. All right, let's plug it in the calculator. Oh, you could not see my notes, could you? There we go. Plug it in the calculator here. So we have 11 times cosine of 50, and we get 7.07. 7.07. And our equation was cosine of 50 divided by 1 equals y divided by 11. Let's see if those are reasonable answers. 11 is my hypotenuse, so 11 is going to be the longest side. My other two sides are 8.43 and 7.07. That makes sense because they're both shorter than 11, okay? So always check for that. Sometimes it gets tricky. You plug it in and you feel like you have the right answer, but you use the wrong thing. All right, so in our work together today, we're going to be reviewing some things, some trig ratios together and be doing an assignment. So I'll see you there.